So in this case, in this two-study guide, you will have examples, which we will go over later, so you have to go over and come with questions. In both study guide, you will have questions on hydrostatics, on buoyancy, and Bernoullis. Okay, second principle. The second principle will be buoyancy and Archimedes principle. Buoyancy. Buoyancy is a force. So what we call buoyancy is a force. Buoyancy is a force. What will be that force? And due to what? When we have an object, this is water. So let's say that we put an object inside water. How will be the object? Heavier or lighter? Lighter. So when you go to the beach and you get a girl or a boy in your hands and you start playing, like we played when we were kids, you remember? Right, oh, nice, and all this. They are lighter or heavier? Lighter. Okay, lighter due to what? Due to what force? The buoyancy force. The force from the water, which is like normal force. The force from the water. But here in the fluid, we would call buoyancy force. So what is the buoyancy force? The buoyancy force appears due to the difference in pressure between the top and the bottom. Since the pressure at the bottom, let me just say, from the force that the water exerts from the bottom and the force that the water exerts from the top. So the buoyancy force, what we call buoyancy force, will be the force from the bottom minus the force from the top. So, since the force at the bottom is the pressure at the bottom times the area at the bottom minus the pressure from the top, area at the top. Let's assume that it's the same area. So, imagine that this is the object and it's the same area to simplify the formula. Where the pressure is greater, at the bottom or at the top? At the bottom. Since the pressure at the bottom is higher and is upward, when you do the net force on this, if this force is greater and this force is smaller, what will happen? The net force will be up. This is what we call the buoyancy force. So because the pressure here is higher and this is lower and this is up, the net force between the force from the bottom and the force from the top, which is the normal force in mechanics, from here, and normal force from here, so we will say from the water on the object. So we will say that due to these two forces, there will be or appears a new force that will be the net force, and that net force will be called buoyancy force, which is upward in this case. So lifting the object versus the weight or the force of gravity. So what will be the buoyancy force there? Because we know that the pressure at the bottom is the sternal plus rho GH, correct? So, but the sternal minus the sternal will cancel out. I just will use the rho GH. So will be the rho of the fluid, because this force comes from the fluid, from the water, which means from the body of water that is below the object. So it's the density of the fluid. Why I am putting density? Because pressure, we found that due to the depth, was rho GH. So will be the rho of the fluid, the volume of the fluid displaced by the object. Because if let's say that it's completely submerged, when I immerse an object here, what will happen to the water? It will go up by the same amount that the object immersed. So I will say the water, the volume of the fluid displaced times gravity. This is mass times gravity. Let me just put it this way. The buoyancy force, the pressure, let me just put it this way. The pressure is rho of the fluid. Let me just put the force, pressure times the area, but this is rho of the fluid. And we said G, H from the bottom times the area from the bottom minus rho of the fluid, G times H from the top. Time A, sorry. Time A. What will be area times volume? What will be the area times the volume? This height. So what will be? It's this height, by the way. This height from here to here. This is, or we can say, which is the same, the area. I mean, we will be this height and this height. So what will be the height from the bottom? Which is the depth. From the bottom is this, and this will be for this one. So what is this? H times A is the volume. So will be rho of the fluid, G, volume, but is the volume. So if I said H from the bottom minus, let me just see, assuming that it's the same area to simplify this. So will be rho G times area times H from the bottom